Well, PowerGen International really is winding down here. It's the Thursday afternoon, and I finally got to catch up with Bill. Bill, you're one of the startup companies here on Initiate this year.
Yes.
You were selected because you've got some pretty innovative ideas.
We do.
You're doing large-scale, long-duration energy storage. So we were chatting yesterday afternoon. Tell me what you're up to.
Well, so we are after large scale, and that's because the renewable world has changed. At one point, many of the people here in the last few years have seen real problems with their plants, their gas plants cycling. But now we have so much renewable power that actually the renewable plants are cycling also. In California this year, we have curtailment, of large-scale curtailment of solar power, which means there's no place for it to go. So the market now is ready for large-scale, long-duration storage.
Yeah.
And that's what we've been working on these last few years, a technology and a patent around how to store energy much more cost-effectively and safer than batteries.
And you're looking at liquid salt.
Right. So liquid salt, that's right. So liquid salt, or molten salt, as it's commonly called in the industry, has been used for many years for thermal energy storage in concentrated solar power plants. It goes beyond that. DuPont and other companies use it in oil and gas and heat treating and so forth. There's a long history of this. So it's a proven technology,
Yep.
and it's a great medium for storing energy. And thermal energy is known to be the lowest cost means of storing energy. The challenge has always been how to make that efficient and cost effective.
Okay.
And that's really what we brought as an innovation. So, can I take you through the process?
Please do, because this is what I was found fascinating. This is
Right.
this is why I'm back.
So we start with renewable power, or really low-cost power from any source. It could be cycled from any place on the grid, but we start with renewable power. It's electricity that comes in from the grid, and we use electric heaters to heat the liquid salt. And we put it in a hot tank. So the hot tank is about 425 C or 800 F.
425.
Right, it's fairly warm.
Yeah.
But that temperature is carefully selected because we can use low-cost carbon steel to contain it.
You were saying to me yesterday that in the concentrated solar plants, it's a much higher temperature.
That's right.
But then you need a very different type of metal,
That's
and it's
right.
far more expensive.
That's right. So concentrated solar, in order to drive efficiency, they go to high temperature. They go to maybe 565 C with their systems.
Okay. Okay.
But in our system, we are able to keep it to use all carbon steel materials. It saves a lot of money in the capital cost of the plant. Now, where do we still need high efficiency, and for that you need heat.
Yep.
So that heat we get from a combustion turbine exhaust. So we combine these things where we charge the salt with low-cost electricity when the sun is shining or the wind is blowing.
Yeah.
And the energy is cheap. When we need to produce power, then we start the combustion turbine, and we have steam available, heated from the molten salt, that goes through a superheater to a steam turbine. This configuration is really novel. We pull the evaporator section, the boiler, from where it normally would be in a combined cycle in the exhaust ducts, and we put it externally. That is a thermodynamic trick, really. It lets us put 3 times more steam into a steam turbine, so we get much more power from a steam turbine than can in a normal configuration. Now, of course, the steam turbine has to be bigger
I was going to
support
say,
that.
yeah, but if I have a bigger steam turbine, then I'm generating more electricity,
That's
so
right.
theoretically I should be getting more money.
That's right. And so that's what this is about. So there's a couple of things about it. We save cost here. We get more power out of the salt compared to these others. We get much more energy per ton of salt that we purchase, so that also reduces cost. We manage to get more power, almost twice as much power from this system as in a conventional simple cycle combustion turbine. So we burn half as much fuel. So so we are the emissions are way lower. Not only are we we're using renewable power to curtail the fuel use. Then the other thing, and people may have heard of the duck curve. It arose in California. And there's 2 problems. One of those problems is this overgeneration, which causes curtailment that we talked about.
That's the solar farms.
The solar farms
I can't. There's no one to take the electricity.
That's right. So that's one problem. The other problem is really an operational problem. When the sun sets, these power plants have to start up very quickly, and they are slow to respond. They are large plants with thick-walled vessels and piping, and thermal stresses are their they don't like thermal stresses.
That's the
right?
evil thing, or whatever,
Evil,
right?
right.
It's bad.
So by moving the heavy walled components from here up to here, we can keep this warm. So when it's time, when the sun sets and the grid needs energy, this plant can start up very quickly.
So I'm not coming from a cold start.
You're not coming from a cold start. That's right. So there's more.
Go on.
But there's more. So one of the other constraints in many combustion turbines is they have emissions controls. Like you have in your car, you have a catalytic converter on your car.
And they're getting tougher in many states and countries.
That's right. And we have catalysts in the exhaust gas of these systems. The catalyst has to be warm. Just like in your car, you may have noticed it smells a little bit when it's cold, right? The same is true here. These need to be heated up. But in the conventional system, with all of the metal in here, that catalyst can't come up to temperature fast. And so the plant doesn't meet its emissions limits until it is fully warmed up. In this system, we can heat it up and meet the emissions criteria much faster.
Okay,
much faster. In a matter of minutes instead of maybe an hour or 2 hours.
Now, there are hundreds, if not thousands, of power generation plants using the traditional gas turbines today.
Yes.
If I go to use this technology, do I need to build a new plant and fit it in? Can I retrofit?
We can do all of the above, but we think the best use of this technology at the moment is to retrofit it. We could either take a peaking plant, a gas turbine peaking plant, and add on the steam cycle and heat recovery equipment and the storage, or we could take an existing combined cycle plant, especially one that perhaps isn't performing because it is not efficient enough to be in the market enough to make money. Right now.
There's quite a few of them that are falling off that.
They're falling off the
economic model.
They're on the bubble, and and so somebody has to decide: will they keep them in the fleet,
or
retire them? Well, a unit like that, we could add storage to it, and we could make it the best performing unit in the fleet. So it is the one that will run most. If you're going to burn gas on the system, this would be the unit you want to burn it in because we burn half as much gas, its operating costs are lower, and it's much more responsive and flexible.
Now, one of the reasons we're chatting late, as they're taking the thing down around us, was you were very busy for the last couple of days.
Yes, I have been.
Now, quick question. So you're here as a startup. What stage are you guys at this?
So we've built the foundation of this, a foundation of technology, of performance numbers. We know our performance, we know our cost. We have created an alliance of trusted suppliers. These include the major turbo machinery makers, all of the brand names, the suppliers of electric heaters like Chromalox, of the salt, Coastal Chemical, the boilers from various makers, all of the steam turbine and combustion turbine makers. And they all like this idea because it's an opportunity, if we're successful, it's an opportunity for them to sell equipment to these plants. So we have now a base of that.
You have an ecosystem.
We have an ecosystem around that. The engineering and construction firms are also looking for that. It's difficult for an engineering firm that does complex projects to make money putting batteries in a container on a concrete pad.
There's not a lot of work.
There's not a lot of work for them. They like this also. So that's the ecosystem. I have a team of colleagues that came to the show with me, and we were out, and we have a broad network, and we were out reaching people. We've been talking to utilities, to independent power producers, looking for opportunities. But yes, we are a startup. We have not yet built one of these.
But you have a lot of patent technology,
right?
And right now you're also looking for investors.
We're looking for investors. We're looking for an A round of investment. I wanted to come back to one more thing about those suppliers, and that is that every piece of equipment that you would see on here is already proven in utility service. What our technology is really, and our patent, is around the novel idea of how one integrates that stored energy into this system. So it's a low technology risk because all of this already exists and is in utility service.
So it's not that there's a brand, this hasn't been invented yet.
That's right.
Technology.
That's right. So now that sets the stage to go out for an A round of equity, and our A round will be targeted mostly for sales and business development to commercialize this technology at a power plant and the necessary engineering support to make that successful. And then we will make this available. It could be used in the transmission grid, it could be used in microgrids, because any size combustion turbine can be used from the smallest to the largest. And
No.
then I think the last thing is about long duration. So
Yeah.
I'm sometimes asked by utilities, because they say, well, we see a lot of 4-hour batteries. Why do I want 24 hours of storage from you? And the answer is that Sunday, for example, as an example, when we had curtailed all of that solar energy. If you have a 4-hour battery, after you fill up 4 hours, you have to go back to
and charge it.
You have to go back and charge it. So on Monday, you use it, and now you have to charge it. And when you charge that battery, you have to go to the grid, and at that moment, it's probably the dirtiest and most expensive plant that will provide you the power to go into the battery.
They've been turned on to meet
Right.
demand.
Whereas we would have 12, 24 or more hours of storage. So we could charge 24 hours on Sunday, and then you could dispatch 4 hours on Monday and Tuesday and Wednesday and Thursday and Friday, and never need to recharge until the weekend. Of course, if there's low-priced energy in the market,
Well, you can take it, right?
We would take
bid,
it.
Just
That's right.
I'll take it now
That's
in a
right.
spot market.
That's right.
And if I may, the capacity, for want of a better word, depends on how many tanks.
how many tanks and how big the tank is. That's right. And so we've looked at a particular size unit as a good one. It's an LM6000. There were thousands of those units made by GE, and typically we would bring about 24 hours. That would be more than 2 gigawatt hours of storage in a compact area.
2 gigawatts.
2 gigawatt hours. That's right. So anyway, back to money. You know, that's what this is about, and that's what we're looking for. That's why we came to initiate. We were really excited to be accepted.
Yeah,
to
you're
this.
one of the 8 companies
Yeah.
out of, I think, 50-something that applied.
Right. This was an exciting thing. This really drove a lot of effort on our part to be ready for this show. It's been a great show for us and a great experience, and I'm just delighted to have been selected, and we've had a great time here.
No, it was one of the you're active on social media as well, so I spotted you before I came here. So, Pintail Power, boys and girls. Hey, I wish you well.
Kevin, thank you.